tools. So as I have already told you, we have a very good team member. They are working in different area, and these are not, you can say, within boundary of Sharda University. Some people from physics department, some people from engineering department. We have a good team of, you can say, materials, synthesis of materials, characterization of materials, and device point of view we have working in. So whole soul, my aim is to give something about, you can say, carbon-based nanomaterial. Carbon-based nanomaterials, why I am focusing, because whole soul device, which I am going to talk, is related with either supercapacitor or solar cell. And supercapacitor and solar cell, both you can say, as a layman, I can say that it is just a device, electrochemical device, which just a sandwich, you can say, bread structure. So there is a, you can say, sandwich structure of two bread sandwich between, you can say, one jam layer or something. So jam layer, or you can say other cheese layer, we are treated it as a electrolyte, and two breads, you can consider it as a two electrodes. So both electrode is composed with this carbon-based, highly conducting carbon-based material. That's why today my talk is a little bit related to only towards carbon-based material. So carbon-based material, the most important things you already know as a player, as a good researcher, as a good scientist, that everything, most of things are related with nanomaterials. I'm not going to tell many things related to nanomaterial because this is not my primary aim to give a little bit glimpse about, you can say, nanomaterials. Many people have already given too many glimpses. And I think next orator from my own university, he's my guru who teach me, Professor R. M. Mehra, who is going to tell you many things related to, you can say, nanomaterials and materials aspect and a device particular. But this slide I want to show in front of all of you. Now you see, it's already as a teacher, I want to see always this slide in front of my students and audience who are, you can say, good listener or good researcher, or you can say quick learner, bright research scholars. You can say it's tail portion. I am not going to tell many more things. Its tail portion is made by some carbon-based material. Only tail portion I am going. This is, you can say many more things. If anybody is interested, I am just going to suggest you that you please read the book by William D. Callister and chapter 1. I think this chapter I always prefer for my own student. And this is the same picture which I have just pasted in front of all of you. If you try to understand, this is the giving this slide, giving you whole summary of, you can say, material science in aviation area. So in different portion, you can easily see they have already mentioned temperature range. So according to temperature range, there are materials name, material category name, like HRSI, AFRSI, FRSI, and so many. So this is just a copy picture, you can say, cross-sectional view of this Atlantis shuttle, which is already now retired from USA. But it gives little bit glimpse about material science. So each part, you can see it's a different color. So this part, which is nearby, you can say, toe portion or nose portion, which is rated by red color, or it's colored by red. It's a different kinds of material. What I want to say in front of this slide, you can say, this HRSI is a little bit related with, you can say, red portion. And this red portion is another kind of material, HRSI. So many people are working to make a very good compact, you can say, device, like you can say any helicopter or any aviation area thing. So different kind of team is working to develop a different kind of material. So it is not possible for any researcher, I can say, in front of, without joining and together, you are not possible to make a whole device. So you can see HRSI, FRSI, and other things. It's according to nomenclature, temperature is also mentioned in this slide. And IMO. Next slide. This slide gives you the table. The flexible, you can say HRSI or FRSI name. So according to temperature range of operation, according to your own need, people have already developed material. And now basic aim, according to your own choice, your own things, and where you want to use, you can develop your own material. Now in last portion, in slides, this last table column, you can see reinforced carbon material, RCC, which is very important. It's also important because there is no lower limit identified till now. And it's a very good material which you can maybe operating temperature is also too much high. And other property is very. That's why it is using in nose caps or you can say edges portion. And now this one is fluctuating. I can say maybe many people remember a very sad history about Kalpana Chawla. It's our Indian astronomer. So that time his shuttle is just broken down or something happened with this material, reinforced carbon-based material. That's why this material is too much important if you are going to work with carbon-based material. So people have used this material according to their needs, according to, you can say, their own suggestion and according to their own choice. So coming to next slide, you can say, little bit I am going to give you glimpse about nanomaterials, which is derived from carbon waste. And this once technology governed by this nanomaterial, that one is known as nanotechnology. So whole theme or my work is directly or indirectly related with nanomaterials and nanotech. Nanomaterials, everybody knows that once your particle size comes in between, you can say 1 to 100 nanometer, then same material property is totally different. Same material, you can say that it's giving different color. As a physicist, I can say it's related with wavelength. But those who are not much aware about physics simply understand this all material property size dependent. Once you reduce their size, their property is totally different. Same material giving different property, and even their structure and other properties also going to. So we are dealing. Today talk is dealing with, you can say, the materials which ranges, which dimension, I think length, breadth or height, light, any one dimension must lie in between 1 to 100 nanometer. So we are talking about carbon-based material, which you can say dimension line between 1 to 100 nanometer. And nanomaterial, simply you can observe, we cannot see nanomaterial. The reason, I think any scientist already know, most of the researchers already know, that you can say diameter of human hair, our own hair diameter is approximately 60,000 nanometer. So 60,000 nanometer is your only hair diameter. And now you are talking about 1 to 100 nanometers. That's already given. I think everybody has got gifted eyes, which wavelength or you can say light range is already fixed. So it's a 400 to 700 nanometers. So behind that one or afterwards, you are not able to see by your naked eyes. That's why you are just dependent on experimental tools, where people have already told you many experimental tools like CMTM and other kinds of tools. But here I want to show, or why I want to tell, that now the materials which I am going to present in front of you, it is going to deal in between dimension point 1 to 100 nanometer. So diameter of DNA molecule, you can say 2 to 12 nanometer. Diameter of hydrogen atom, it's already calculated 0.1 nanometer. So my whole talk is related to nanomaterials and nanotechnology. Nanotechnology means once you are applied this nanomaterial, which is you can say nanomaterial, and then application point of it's known nanotechnology. These two gentlemen, everybody who is working in nanomaterials and nanotechnology, always highlight these 2 points. Two gentlemen, they got Nobel Prize, and I think only the people who are working at least know that they are pioneer work from, you can say, Feynman or Lay. So one have given is that how you are going to following two approaches. There are two approaches to make nanomaterial. First one is known as top down, where you can just, you can say, started from a bigger particle and moving towards a smaller particle. This is known as top-down, and one gentleman given a bottom-up approach. So both have already got Nobel Prize, and I think I am not going to discuss too many things. It's already in literature point of view. So the question is, why people are always like small and smaller things? The answer is also written. Everybody do not want to carry bigger things right now. So that's why always people are thinking to make nanomaterial. And on basis of this nanomaterial, we have always tried to do something to make device point up. So basic physics behind that one, I am also not going to, you can say, tell many more things related to this. The basic phenomena which is going to govern this nanomaterial is known as quantum confinement effect. As a layman, I can understand that the materials or nanomaterials, if I am working with conducting nanomaterial, there are two levels. One is known as valence band, another one is known as conduction band. And these bands is also, you can say, cut slice wise. So it is band, not band. It is a band of two many slice, you can say, piece. So one slice piece is known as valence band, another one is known as conduction band. In bulk material, you can say very easily, bulk materials, this valence band and conduction level is way too much close. And the gap in between valence band and conduction, you can say Eg, band gap. Now what happened in nanomaterials, these bands is already broken into too many confinements. So you can say now we have a 4-layer in bulk material. Now once you make same material nano size, then this band are going to split in sub-bands. And then you can see there are many transition passes. One can take a jump from, you can say, lower state to higher state, so many transitions. So that's why this phenomena is known as quantum size effect. And many more people are working in this theoretical as well as experimental thing. Now I'm giving you just example. I already told you that most of nanomaterials, in nanomaterial case, everybody read a one definition that material property is size dependent. And this is two example. You can see bulk gold. Every people love it. You just make a gold particle, you can say 1 nanometer. Its color is totally different. Its structure is also different. Its property is different. And same gold material, if you are able to make 20 nanometer gold particle, its color is totally different. Its structure is also different. And if you are able to make 100 nanometer, more towards nano, then it's, you can say, total purple pink. So same material you can develop, and it is nothing related with only color. Total property is going to change. So according to our device need, I suggest all of research. I am going to suggest at least young researcher. Once you are going to enter in any area, try to learn something basic thing behind that one. Otherwise, you are going to put a, you can say, a small piece in a long range, you can say long range river or something like that. There is no evidence of it. So try to understand some basic physics behind that. Without understanding, if you are just going to enter in this area, in my opinion, you got nothing. So these are the old slides. You can say if you are going to move from bigger particle to nanomaterial, then every property is going to change. Maybe structural property, electrical property, magnetic property. Now I am coming to my main own topic. You can say why I am choosing carbon. Carbon, just to give little bit glimpse about carbon. I'm not talking about other kinds of material. Now my whole talk is derived towards, you can say, carbon material only. So carbon is one beautiful material. Chemistry people also love it, and I think as a material science people, everybody, no one material scientist is fulfilled condition because it's a base. You can say chemistry point of view, I can say chemistry in two areas. Everybody knows organic and inorganic. So organic, everything is related with carbon. So you cannot move without carbon. Everywhere you can find carbon. Its melting point, I have already mentioned here. Atomic radius people have already calculated. So nothing about that one. It's already, you can say, in nanomaterial range. And it is basis of all organic compounds. So everywhere, if you are anybody can guess that anybody is talking about organic means something he or she is going to talk about carbon-based or carbon. And 10 million carbon compound already discovered. So this is beauty of the, apart from that one, the another beauty of these material, carbon-based material, there are three allotropes of carbon. One, which is hardest one material ever known, which is known as diamond. It's, you can say, hybridization point of view is totally different. I'm not going to talk about hybridization. So one, you can say allotropes is diamond. Second one is graphite. And last one, or you can say third one category is fullerene or carbon nanotubes. So graphite and fullerene nanotubes, I'm not talking about fullerene nanotubes. Little bit, I'm going to give you glimpse about this graphite. Because using this graphite source, we have derived, you can say, carbon-based material, not graphite. You can say we are not taking graphite. We have derived carbon from plastic waste, and then we are trying to make, trying to use it in, you can say, device point of view. So beauty of this carbon material, or you can say, just take an example of carbon nanotube. I can say in front of you, giving this example of carbon nanotube, I am trying to give you a little bit glimpse about importance of carbon-based material. This material already discovered in 1991 by Ijima. And you can say, in my earlier slides, I can say this slide, that anybody can simply take graphite seed. But what is beauty of this material? The beauty of this material, this is layered structure material. You can see in this picture. There are three layers. Already I have mentioned 001 HKL value. So three layers. So it's a layered material. And if anyhow, I don't know, people are using too many different methods. If you are able to take or separate it one single layer, that it is known as graphene. Conducting material ever known today. Highly conducting, and I think people already got Nobel Prize in this area. So if you mold this graphene in sheet or tube shape, this is known as carbon nanotube. And it's a single sheet, it is known as graphene. So all things you can say base is graphite. No one can say that I can make carbon nanotube because without using any carbon source. So you can say graphite sheet is a just carbon source, which is basic material for making graphene, or you can say carbon nanotube. So one graphite sheet, or maybe multi-layered, you can say graphite sheet, if I am able to mold it in tube shape, it is carbon nanotube. If you are making it a sheet like our mat, it's a single layer is known as graphene. So carbon nanotube is a very wonderful material. People have already discovered. It's earlier and it's already discovered in 1991, you can say. So 1991 it's discovered and it's already defined that single layer of this material is, you can say, graphene. Now you see, the beauty of this material, there are three possibilities I can say in front of all audience, that suppose this is graphene sheet, I can say, simple. So there is possibility to mold it if I am going to make it nanotube. There are three possibilities only. Either I can mold it in our length side, making tubes, or maybe you can say our breadth side, or maybe in between that one. So just according to their symmetry, if you fold it, this material, the same material is giving different structure. So carbon based, you can say graphene or graphene oxide material already give you three structure, and each material property is different. So this is wonderful material, I can say. Although I am going to tell in last moment what is disadvantage, but advantage, now I am talking about advantage. This is wonderful material. It's already from three, you can say, structure, and each structure is giving you different properties. So carbon is a material using which you can make, you can say metallic or semi-conducting carbon-based material. It's already defined. According to their structure, you can mode it and then you can cut. So these are some things related to carbon nanotube already in literature. I think I'm not going to give you because it's a bound of time. I want to impose something about current research work, which I want to talk here. So this one basic, I think, definition is already covered in literature, high aspect ratio in case of nanomaterial. This one is the property, give this material a wonderful, you can say, glimpse and other things. So these all things are related with carbon nanotubes. I'm going to tell. Now I am coming to my main topic. My main topic is related, which I want to give a little bit glimpse. And well, as a good researcher, we found that you can say we are trying to give something for nation. We always follow the one, you can say, mantra of our Prime Minister Modi ji, One Bharat and Swachh Bharat. So my whole soul talk is related with, you can say, one aim. And just proposing the same recently, I think Amit already know, recently I got CST UP project of 14 lakhs from government side on this particular project. So in this project, what we propose, we have already discovered. We have not discovered. We have synthesized carbon-based material, just thrown bottle, which is, you can say, single-use plastic. So Modi, Prime Minister Modi already tell in front of nation that we are going to ban this single-use plastic. So that time, this idea just came in our COVID pandemic situation. We have collected, after COVID pandemic situation, we have collected these bottles within Sarda boundary. We have processed to make it graphene oxide, and then we derived this graphene oxide, and we try to use it in, you can say, supercapacitor and EDLC, electrochemical double layer supercapacitor, and DSCC, dye-sensitized solar cell. So dye-sensitized solar cell and supercapacitor, I'm not going to, I have not enough time. Anybody can, I think, discuss me after this talk or maybe in later time using my email ID. I'm always free for all my students, all for my listener and good wishes. So dye-sensitized solar cell or supercapacitor, you can, as a layman, I can understand that it is a device composed of electrolyte sandwich layer in between two electrodes. So in DSSC, it's known as anode and cathode, and EDLC, it's known as simple electrodes. Not too much different. So in DSSC area, working electrode, we cannot use this carbon conducting. We are using this carbon conducting material in, you can say, counter electrode, because counter electrode and working principle is something related with electron conducting material. So we have tried to derive this carbon waste from, you can say, plastic waste, carbon material, and try to use this coating of this carbon waste material in counter electrode of dye-sensitized solar cell. And in EDLC, it's also, you can say, sandwich structure. So polymer electrolyte, we are very rich. It's God gifted, not God gifted, you can say my supervisor gifted, which is also God for me. Let Professor Suresh Chandra. So polymer electrolyte, we know. Everything we have maximized with Dr. Amit Saxena. So we are just trying to capture this whole soul idea from government and put in front of government. And we recently, you can say, got a good project. And dye-sensitized solar cell, we have derived this carbon waste material and put on counter electrode. And EDLC, we put it in, you can say, our conducting carbon material, conducting carbon current collector material. Electrolyte, we put same, and using same electrolyte and this graphene oxide, you can say, graphene oxide, which is derived from plastic barrier. We have published a very good paper in, you can say, Nature Scientific Report last year, and it is published by my own student. I could not say correctly because it's published by my own student and my own collaborator, which is not, you can say, other than Professor Nand Gopal Sahu from Kumar University, Nainital. So I already told you that without making hand, it is not possible. So once we put this paper in Nature Scientific Brief Report, you can say, that time it's only published due to comment that this is one paper which gives that using same electrolyte and single-use plastic derived carbon-based material, you can at least derive some, or you can maybe explain something related to device application point of view. So these are some results which I am not going to tell. Anybody can interested, you can see, or you can maybe read this paper and then discuss with us. And I think now second paper, which is very recently published, which is also related with same carbon material which is derived from plastic waste, single-use plastic waste, and which is published in very good journal. Now, I think without that one, this third one paper I want to highlight in front of it. This is everybody who is working in solar cell now. Those who are earlier working with dye-sensitive solar cell, you can say now they are take a little bit gym in perovskite solar cell, because perovskite material now play a dominant role in electrode material, you can say, in front of, in a replacement of dye. So we also use this carbon-based material in perovskite solar cell. We got very good, you can say, result. So same carbon material, you can say, which is derived from this plastic waste carbon, we have already used in EDLC, we have already used in perovskite sensitized solar cell, and I think we have published a very good paper. We also got a good project from government side, and I think I have enough time. So, how you can say at least 10 minutes. I mean, how much time I have?
You can continue, sir. You can continue till 11:30.
Okay. Okay. So I think before I am going to conclude, I have enough time, so I am giving a little bit glimpse about other things related to dye-sensitized solar, how you can develop a dye-sensitized solar cell in your laboratory. And in front of you, these are some of my collaborators. They are always help me. So this is my formal duty that I am going to give little bit glimpse. So they are very supportive. Anybody can take their help if you are going to work in this, you can say, supercapacitor or dye-sensitized solar cell area. So I think I am going to quit this slide, and if Amit permit me, I am going to upload a new slide, which is related to dye-sensitized.
Yes, sir.
Okay.
Okay, sir.
So I think I am going to start this slide, and I am going to share some new slide which is correlated with, you can see, our earlier things. And just give me a little bit time, only 1 to 2 minutes. In between that one, I can say that in a laboratory point of view, anybody who is working in this area, particularly in solar cell or EDLC, those who are working in carbon-based material, any time, he or she can contact with us to develop some electrochemical energy. And recently, we are also focusing, you can say, our little bit study towards battery application. So battery application, I'm not going to tell you something about that one. I am going just searching my slides which is related with this DES. Okay. So in front of you, I think I am giving you this slide, and this slide is related with something our earlier work, which is related with solar cell and supercapacitor. So, Amit, can you see my slide? No.
Not yet, sir. Not yet.
Okay, just I think, Amit, now I have shared another one slide.
It's
Dito-
visible, sir.
Yes, sir.
It's visible, sir.
Okay. Okay. So I think now I am giving you a little bit tips about the things which I already present in front of you. This is, you can say, my teacher or my guru. Earlier, you can say Professor Bhaskar Bhattacharya, who is currently working in Banaras Hindu University. And with their blessing, Professor K.L. Chopra, you can see here, he just inaugurate our own laboratory, and I think I am blessed with this, can say, researcher. And now I think I am just going to talk to you something about this only one slide. Yeah, this one slide. This one slide give you little bit glimpse about how we are making, you can say, dye sensitized solar cell in our own laboratory, just to train our BSc and MSc people. So you can say dye sensitized solar cell using carbon-based material. I'm going to talk in last one by 2 to 5 minutes. You can say it's simply two electrode material, or you can say you just take a two conducting piece of conducting glass, which is known as FTO nowadays. Earlier people are using indium tin oxide. Now people are working with fluorine doped tin oxide, FTO. So you can say it's a two piece. My first slide, this slide, you can say first picture show you it's just sandwich, working electrode and counter electrode dye sensitized solar cell. And in between that one, you can easily see the red strip. This red strip is nothing. It is polymer electrolyte which is dipped in dye solution. So since our dye, you can say, is a ruthenium based dye, and when your polymer electrolyte is going to soak this dye, its color is totally different. So this is one dye sensitized solar cell people can make easily in our own lab. Just cut a two small piece of FTO glasses. If you are considering one electrode, as you can say working electrode, you just put a layer of any wide band semiconducting nanomaterials, porous nanomaterials. People are generally using TiO2. Some people are also using zinc oxide. And then you can sintering it in 500 degrees centigrade for 30 minutes. And then put this whole thing in dye solution. Just wait one day, take it outside, and then it is dye coated, you can say, working electrode or dye sensitized solar. Another or counter electrode, simply nowadays we are saying that you take FTO, wash it thoroughly, and then put a layer of, you can say, graphene oxide. Earlier we are using platinized, you can say, FTO. Now we are using graphene oxide coated FTO, and we got a very good result. And polymer electrolyte is sandwiched between these two electrodes. So you can say it's a sandwich, smaller device. Anybody can develop in a laboratory. It's not too much easy as it's looking like. But if you have some facility, like earlier already, I think Amit told me that in your own institute, I think there is a good facility of, you can say, thinking deposition and other things. You can think about making a sandwich, you can say sandwich flexible dye sensitized solar, which is all derived from polymer. And polymer, I can suggest you, there is one polymer which is known as PET. And this PET is a, you can say, single used plastic. So that one is also bigger challenge for you can say environmental pollution point of view. So anybody can develop. In this, you can say flexible dye-sensitized solar cell. And if you are just taking in front of this FPO glass, you can say metal sheet, and just coat with this graphene oxide in both electrodes and put the same polymer electrolyte sandwich between this. And this polymer electrolyte, I think Amit is known better than me. It's flexible, and you can say it's gel type. So you need not put any hole or drill or something like that. People are putting in, you can say making solar cell and other things. So this is due to a polymer electrolyte itself. So same you can say electrode with carbon coated and base material is your you can say your metal electrode. You can make a very good supercapacitor. You can say EDLC because supercapacitor is two types. One is EDLC, another is pseudo capacitor. So those people who are working in EDLC can think only about carbon-based material because both principle is totally different. One is working in ferritic principle, another one is working in non-ferritic principle. So those who are working in EDLC can think about carbon-based material. And since in our own laboratory we have developed single-use plastic derived carbon waste which can be successfully used in counter electrode of dye-sensitized solar cell or in place of perovskite solar cell counter electrode along with the, you can say using it as a both electrode coated with this graphene oxide and sandwiched between polymer electrolyte. So using same material, same electrolyte, you can say anybody can develop a good, you can say efficient dye-sensitized solar cell or perovskite sensitized solar cell, or you can say electrochemical, double layer supercapacitor. Now we are thinking to derive some battery material because recently we got that government have. I want to tell because if you are a good researcher, you just catch whatever government is going to announce. Now recently everybody knows that government focus his whole study on replacing, you can say, biodiesel, not biodiesel, maybe diesel or petrol. Now people are thinking about hydrogen to revive this pollution and other. This carbon is also very good source of hydrogen storage. This carbon material can be used to derive some other kind of device, like battery, you can put it as a doped, you can say electrode, you can just put a layer of this carbon. And based of this one, as I already informed to my, you can say, colleague or student, I mean that we have already submitted a very big project, BRIC, and we have successfully completed its second, you can say, presentation. So we hope for better for this carbon-based material. We have tried to use these materials as our own needs, our researcher needs, our nation needs. So it's for, you can say, last but not least, I can say in front of all audience that if you are a good researcher, then try to open your eyes. What government wants to do from your own side. Not only government, maybe if you are serving something for your society, then I think your research purpose or research other things are going to fulfill. Otherwise, I think it's not complete as a researcher, I feel. So thank you very much for giving me this opportunity, and I think I most welcome for any comments from researcher side or faculty side or anybody who is presenting in our. So thank you, Amit. I think this is end from my own side, and I am welcoming if there are some questions.
Yes.
Thank you very much, sir, for your presentation. You have covered so many things regarding the carbon waste and all. Now the session is open for the queries. Participant can put their queries in the question and answer tab or raise their hand. we will allow them to talk. Anyone who want to talk with the experts, they may raise hands. We will allow them to talk.
I think as a good teacher, Amit is in front of me, so no student is going to want to talk with him because he's a good teacher. I know. I feel in front of all of audience, I am a good researcher, but not good teacher. But Amit have both qualities.
No, sir,
So, sir, you have explained very well, sir. No problem.
Maybe one remark is from Dr. Anirban Gupta. I say that today's session is very important. Can we have the recording for future reference? Yes, we will provide the recording. We have the recording of all the sessions, and we will provide it through the Google Drive. We'll share the links with all of you. You all can download that links. You can get it as you want, and when you want, you can listen. I have 2 or 3 questions.
Yeah.
Like nowadays, we are moving from like PEO is already exhausted. Like if you're coming down to the PEO materials or polymeric materials, PEO is something where I think it's over 7 decades people are working. And once we are coming to one single-use plastics, there are few limitations with the single-use plastic when we are adding some salt. Like I tried to get some polymer film directly by using the single-use plastic, and I was not successful to get dissolved in some ethanol or ethanol. Without extracting carbon or without thinking about carbon out of that single-use plastic, can we make a thin film of this single-use plastic directly by adding some salt?
I think it's a smart question, Amit. I really appreciate this question, and I think now I am able to give you answer about that one. Because earlier, since you already know that our backbone is related with somehow concentrated towards polyether, either PEO, PBA, PBC. So now earlier people are already used this material to developing, you can say, good electrolyte. But as I already told you that you just open your own eyes in whatever the government wanted to. Now I can tell in front of you that we have derived this carbon graphene oxide from PEO itself. PEO now we have developed in our own laboratory. We are going to got, means we already got very good, you can say, yield product carbon itself from PEO, and then you already know you are master in PEO based electrolyte. So very recently we are going to invite you to publish paper Nature along with us, you can say.
I love to, sir. I love to do
all PEO based supercapacitor electrochemical, where we got a very good result. And this area is almost, you can say, not too much explored. Using single plastic, people have already discovered too many plastics, like pipes, you can say bottles and other things. But nobody reported, I think not, I can say nobody, very less report came in literature with poly. So now we have moving forward in our own laboratory to make, you can say, polymer electrolyte, not only for polymer as a electrolyte. Now we are derived this carbon, very good carbon quality conducting, you can say, graphene oxide. And we are going to communicate that paper also. We are in process to communicate this paper in, you can say, Nature or something like that one.
Great, sir. Great. I suppose I would love to be a part of that work again. So long that I'm not into that laboratory, and I'm missing that laboratory a lot. That laboratory really a very
now
big
you say, now I see it's not, it's already COVID give us too many platforms where I think physical appearance is also important, but not too much.
Yeah.
80% you can say our conductivity maximum always came in 80-20, you already remember. Now, as a researcher, I can say 80% come from online, 20% offline.
Yes. I think one more person who was asking to unmute himself, like Bhavana Singh. Bhavna Singh, you can speak, you can ask your question. I allow you to unmute yourself. Hello, Bhavna Singh, can you hear me?
I think Amit, you gave them my email ID.
Right, sir, right.
So that they can directly interact with
Contact to you, right.
Yeah, I think I always love
might be one candidate that contacted you, Himani Chaudhary, I think. She taken your number through me. She was interested to contact you. So might be she will contact you soon.
And I think before going to, you can say, conclude this session, I want to say something in front of that. Try to send your bachelor or master student, because they are very good culture, or you can say lover with these new topics.
Yes.
And whatever I am going to present in front of you means most of people already agreed with me. I think we all are busy apart from research, some different kind of work. If you train your own student, you can fulfill all those things. So I just know, I don't know the process, how we can collaborate with each other. So I request with this platform to your higher authority, you can send your bachelor, master.
Certainly, sir. Certainly, I will take this point to my superior authorities and will try to collaborate in some way so that student exchange or knowledge exchange program can be done with us. Yeah. It will be wonderful for the student point of view. Thank you, sir.
Thank you very much, sir.
So should I stop my slide?
Yes, sir. Now.
So if you permit me, now I think Amit, I am going to attend another one meeting. You already know.
Yeah, just I wish Dr. Amit Saxena to put the vote of thanks to Professor P.K. Singh, sir, on behalf of our university.
So thanks a lot. Thank you very much, sir. It's my privilege that I'm giving vote of thanks to my teacher, my mentor, my guide also. So on behalf of Shri Vaishnav Vidyapith Vishwavidyalaya and from Department of Physics, I extend my heartily thanks to Professor P.K. Singh for giving his wonderful talk. He's taken out the time from his busy schedule. Now he is busy with all major activities at there, and recently they have been passed through next activity over there. Out of this, he has taken out time for us. Thank you very much, sir. And we would like to call you sometime to our campus in offline. Thank you, sir. Thank you.
Thank you.